Hello and welcome to the channel Understanding Concepts of Physics. Up till now we had discussed about oscillations and linear simple harmonic motions definition, and today we are here with the differential equation of linear simple harmonic motion. So let's just understand what a differential equation is. In simple words, an equation which contains derivatives, which contains the rate of change of variables, is what is called as differential equation. Now actual definition and how it works is basically a topic of math, but here we are only going to understand how we are going to derive this differential equation of linear simple harmonic motion. Differential equation in itself is a very deep topic in maths, but we are just going to see how we go to derive to differential equation of linear simple harmonic motion. So let's just quickly start. I start with Newton's second law. Force is equal to mass into acceleration, and force can be written as minus of kx from Spring's constant, and acceleration can be written as dv by dt. Now there is a prerequisite over here, is that you should be knowing that if you differentiate displacement, then you get velocity, and if you differentiate velocity, you get acceleration, and if you integrate acceleration, you get velocity, and if you integrate velocity, you get displacement. So I think so you should note this, and this would be needed in many of the places. So I'll just follow that part. So acceleration can be written as dv by dt, as this is the rule. So it's written as dv by dt. Then dv by velocity is basically displacement upon time. So because velocity is displacement upon time, wherever there is was v, I have written it is dx by dt, and this d by dt was as it is. Now this derivative of that means there is two derivatives of displacement. So I am just writing as d2x upon dt2. Mind you, this is not a square, it's just a second order derivative. That means twice the derivative of displacement with respect to time will give you something called as acceleration. It's something like you differentiate it twice. Once you differentiate and then you do it again. Then comes a differential equation is always written, an equation, or not even differential equation, any equation is written in the form as equal to 0. So I'll just move this minus kx to the other side, so it will become plus kx, and this remains as it is on one place, so this is not changing sign. Then in a differential equation, whenever you have the highest order, that is this is the order of the differential equation, you generally keep the coefficient as 1. So I'll just divide throughout by m. So I'll get 1 here, and this is divided by m, this is m, and m gets cut, and k by m remains as it is. Then, as we have discussed in the last video yesterday, that omega square is assumed to be as k by m. I am going to prove this. I am marking on my words. I'll be proving this omega square is equal to k by m in very short time, because it's very near, like where we are going to consider this now. Now this equation is what is called as the differential equation of linear simple harmonic motion. So in it's a very short derivation, and it's a very mathematical one, so you can just see it can be done very easily. Now you can go and check for the previous video to find out acceleration. However, you can do it from here as well. You have this differential equation, and this differential equation is d square x by dt square plus omega square x is equal to 0. I'll just move this omega square x on the other side, so I'll get minus of omega square x. Now derivative of displacement with respect to time twice is nothing but acceleration. So acceleration is minus omega square x. So if you see in this derivation, we have done the differential equation as well as the acceleration as well. However, in the previous video as well, we have done for acceleration. So any which way you can just follow any, actually they both are same, one and the same thing, but you can just follow up whichever way method you like to. Also in the coming video, we are going to discuss something about velocity, and if you see we started with an equation f is equal to minus kx, the equation which we used in the we derived in the previous video, and we derived this differential equation, and using this differential equation I derived an acceleration ka formula. Now when I am going to do this velocity tomorrow, maybe in the coming video next, acceleration can be used in order to derive for velocity. So in oscillation, everything is like linked in a chain, so one after the other, one after the other. So just keep on deriving and you keep on getting the newer equations. Yes, definitely it needs a bit of math, the trigonometry, the calculus part, but yes, if you are comfortable handling those things, those subjects, then definitely this would be one of the easiest topics of physics. Thank you so much for watching. Subscribe the channel in case you have not done so, and keep watching the videos in a series. Alone video will not help you. Just keep on watching in a series. Watch it from the playlist and you will definitely get the entire course. Thank you so much. Have a nice day. Bye.